Section 4.5 is called linearization. Essentially what we're going to do in this section is find the equation of the tangent line to a function at a particular x value, and then use that function, that tangent line equation, to approximate values of the function that are pretty close to that point of tangency. So we're going to start by finding a tangent line to a function f at a place where x equals a. Well, now if I want to do that, I'm going to need an x comma y, an ordered pair. So my x is x equals a. I'm going to plug that into my formula to get my y. It's going to be f of a. And my slope is going to be the derivative evaluated at a. So now I'm just going to use the point-slope form to write that equation. The only thing with this point-slope form is it's not actually written as a function. A function would have y all by itself on the left and everything else on the right. So this is the one extra step we're going to take when we talk about a linearization. We're going to take this version of the tangent line equation and move this minus f of a term over to the right so that I get y by itself. If you want to memorize a formula, this is the formula you end up with. But again, this just derives from using point-slope form for the equation of a line and then scooching everything but y over to the right. Your choice. The cool thing is, now that I have this formula for the linearization, a formula for the tangent line to the function, as long as I pick an x value that's pretty close to the a that I started with, this linearization is a good approximation of the actual function. And we're going to use it to approximate function values next. So here's an example from your book. It's got two parts. I've been asked first to find the linearization of f of x equals cosine of x at x equals pi over 2. And then second, I've been asked to approximate cosine of 1.75 without using a calculator, which is pretty amazing because nobody knows the cosine of 1.75 off the top of their head. So two steps. My first job is to find the linearization. Remember, that just means the tangent line equation with y isolated on the left and everything else scooched over to the right. So what kinds of things do I need to write a tangent line equation? I need an ordered pair. I've been given the x, that's pi over 2, so I'm going to plug that in to my f function to find the y. Then I'm going to need the derivative so that I can evaluate the derivative of that same x value and get my slope for my tangent line. Okay, so here's a bunch of that stuff that I just listed. I know my x is my a, which is pi over 2. I know f prime of x is f prime of cosine, which is negative sine. Now I can evaluate the derivative at the x value I care about. So f prime of pi over 2 is negative sine of pi over 2, which is negative 1. The one other thing I didn't remember to write in this slide is I need f of pi over 2. I need the y coordinate that goes with my x coordinate. So what's the cosine of pi over 2? It's 0. And now we can see I can write my tangent line equation. Could either use point-slope form and then scooch that f of a over to the right, or I can notice that I've got the linearization formula written here, and I can choose to memorize that. So f of a is 0, so I have 0, plus the slope, which in this case is negative 1, times the quantity x minus the original x value, which was pi over 2. So I can take that and multiply it out. You don't have to. Here's what I've got. The simplified version, my L of x formula, my linearization is negative x plus pi over 2. So this is the answer to the first part of their question. Find the linearization of cosine of x at pi over 2. Now the second step, they've asked us to use that linearization to approximate cosine of 1.75. Well, cosine of x is pretty close to this linearization of x as long as I keep my input value pretty close to pi over 2. And 1.75 is pretty close to pi over 2. So here I'm going to find the cosine of 1.75. The number inside the parentheses, that's my x now. So notice here I have a negative x in my linearization, so I'm going to have negative 1.75 plus pi over 2. And if you compute negative 1.75 plus pi over 2 on your calculator, and also compute cosine 1.75, you'll be shocked how close they are.